Okay, here we go. Again, this meeting's being recorded, and we're in 3.5 today. So let's jump into that. Nope. All right. So 3.5 is equations with absolute values. Right. So we've seen the last section we talked about, we saw equations with rational expressions in them, and we saw equations with square roots in them. Now we're just going to take it one more step and say we have absolute values inside these equations, and the absolute value of some number, right, is listed like this, just two bars, vertical bars on the outside of whatever it is that you're taking the absolute value of. And so you would read this as the absolute value of x. Right? And it reports the distance that x is from 0. Or whatever's inside the absolute value, it reports the distance that thing is from 0. And it doesn't tell you distance, it doesn't tell you direction, right? So the absolute value of, like, say 3, well, 3 is 3 units away from 0, so the absolute value of 3 is 3. But likewise, the absolute value of -3 is also 3 units away from 0 in the opposite direction, but we don't worry about direction with the absolute value. It always puts out the positive value of that, right? So an absolute value is either going to give you a positive value, or the only other option is that it'll give you 0, because the absolute value of 0 is 0. So you'll never get a negative out of an absolute value. You'll always get either positive, or in that off chance you get 0, you get that. So because I have things like this, the absolute value of 5, for example, is 5, and the absolute value of -5 is also 5. Right? If I have an equation that comes down to the absolute value of my unknown number is 5, what could those possible values of x be? Well, I have them right here. The absolute value of 5 is 5, but the absolute value of -5 is also 5. So this tells us then that x is either equal to 5 or x is equal to -5. Those are my options, right? And so in general, we see this. If you have something in an absolute value, so let's say the absolute value of x is some value a, then x is either equal to a or x is equal to -a, because the absolute value of those two things is both a, as long as a is greater than or equal to 0, right? And then we say that because having something like the absolute value of x, if that's, say, -4, this is meaningless, right? And there's no solutions here. There's no number that is -4 units away from 0, because that absolute value always gives you the positive distance that that number is from 0. So if you end up with the absolute value of x as a negative number, then that's in the garbage and you don't do anything with it. Right. But we'll see examples like this. The absolute value, and it doesn't always just have to be an x, you might have an expression in there. So in this case, the absolute value of x minus 3 minus 1 equals 4, right? And we can still use the addition principle. We can still use the multiplication principle. But what I want to do here is isolate the absolute value. Now the absolute value is kind of like a grouping symbol, like a parentheses or a bracket or things, something like that. So I don't want to take anything in and out of it. What I want to do is get everything else around it away from it. So in this problem, I would just add 1 to get the 1 away from it, so that I have the absolute value of whatever the expression is equal to some number. And then I can use that principle that says the absolute value of something equaling A means whatever's inside the absolute value is positive A or it's negative A. So in this case, what's inside the absolute value, which is x minus 3, is either equal to 4 or x minus 3 is equal to negative 4.
Wouldn't it
Savannah, I didn't catch that.
wouldn't it be fine because you added 1 to both sides, so 4 plus 1 is 1.
Yeah. Thank you. Zoop. 5. There we go. Yes, thank you. Yeah, so I add 1, of course, 4 plus 1 is 5. And so what happens then is that either what's inside the parentheses here, this x minus 3, right, that is either the positive of 5 or the opposite, which I didn't write because I goofed up. There we go. So that's what we have. It's either equal to 5 or it's equal to negative 5. And then I just solve both of these individually. So I add 3 to both sides. This becomes x equals 8. Or add 3 to both sides, and x equals negative 2. And then, of course, I can check. I'm going to check 8, and I'll check negative 2. But plugging 8 into the original equation gives me the absolute value of 8 minus 3. Minus 1 should equal 4. 8 minus 3 is 5, so still in the absolute values. It's the absolute value of 5. Minus 1 should equal 4. But the absolute value of 5 is 5. And 5 minus 1 is indeed 4, so that one works out. Checking negative 2 gives me the absolute value of negative 2 minus 3. Minus 1 should equal 4. But minus 2 minus 3 is negative 5. And the absolute value of negative 5 is 5. And 5 minus 4, 5 minus 1 is 4. And so that one works out as well. Let's take a look at another one. Let's look at, let's say, the absolute value of 4x minus 3 plus 1 equals 7. Again, the first thing I want to do is isolate the absolute value. So that means this whole expression right here, I just want on one side and everything else away from it. And I don't want to pull anything out of the absolute values. I just want everything that's not inside the absolute value out of there. So I'll subtract 1 from both sides. The absolute value of 4x minus 3 is left on the left-hand side, equals 6. And at this point, that's when I break it up into 2 equations. This tells me that either what's inside the absolute value, which is 4x minus 3, is either equal to 6, or that expression inside the absolute value, 4x minus 3, is equal to negative 6. So this should always be the same. 4x minus 3, 4x minus 3. Don't change that. That should always be the exact same thing that was inside the absolute value expression. We'll just solve for it now. Add 3 to both sides on the left equation. That gives me 4x equals 9. And then divide each side by 4. And I have x equals 9 over 4. Or add 3, add 3. This gives me 4x equals negative 3. And divide each side by 4. And I've got x equals negative 3/4. Okay. And again, we can check this. And it's not a bad idea to check them. So here we go. I'm going to start by checking 9/4. That leaves us with the absolute value of 4 multiplied by 9 over 4 minus 3 in absolute values, and then plus 1 should equal 7. Hope so. The 4 cancels with the 4 to give me the absolute value of 9 minus 3. And then plus 1, again, should equal 7. The 9 minus 3 is 6. And the absolute value of 6, of course, is 6. And 6 plus 1 is indeed 7. So I will check now negative 3/4. Well, that gives us the absolute value of 4 multiplied by negative 3 over 4 minus 3 plus 1 equals 7. And we're hoping it does. But the 4 again cancels with the 4 in the multiplication. So inside these absolute values, I'm just going to mess with everything until I get it down to one simple number. And then evaluate the absolute value. So I'm left with negative 3 minus 3. But that, of course, is negative 6 inside the absolute values. The absolute value of negative 6 is positive 6. And 6 plus 1 is 7. That one is true. That one works. We okay with that? Questions on it? Okay. Let me see if they've got. Let's do this one here. They don't get too ugly in the book, which is good. But let's look at this guy right here. 12 minus the absolute value of x plus 6 equals 5. Okay. Now again, I want to isolate, right? The very first step I should always be doing is isolate the absolute value. So in this case, I want this 12 out of here. So I'm going to subtract 12 from both sides. So 12 minus 12, that's gone. That's 0. But I still have this minus right here. Yes, Alex, go ahead.
Wouldn't? Oh, never mind. You answered my question.
Okay. All right. So we still have the negative there. So I have minus absolute value of x plus 6. And then on the right-hand side, 5 minus 12 is negative 7, right? I still want the absolute value completely isolated, right? And so I want this negative out of here. And so I'm going to multiply the left-hand side by negative 1, and I'm going to multiply the right-hand side by negative 1. The negative with the negative 1 cancels with the negative in front of the absolute value, and now I've completely isolated that absolute value. And I can break it up into 2 different equations. Whatever's inside that absolute value is either equal to 7, or the expression inside the absolute value is equal to negative 7. And so I subtract 6 from both sides. I get 1 or negative 13. And then you can check those, right? I'll leave that to you. But that's how you deal with those. The one funky one that you might see, I don't see one like this in the list of problems that I'm looking at, but just do be aware of something like this. If you have something like, say, the absolute value of 2x minus 5 plus 8 equals, let's say, 3, right? Again, the first thing I want to do is isolate that absolute value. So I'm going to subtract 8 from both sides. The 8 cancels out, isolates my absolute value. So I've got that 2x minus 5 in absolute value on the left equals negative 5 on the right. I'm going to quit. Can anybody tell me why? And the reason why is there are no solutions because the absolute value is set equal to a negative number, and that's never going to happen, right? So I can just quit right here. If my absolute value ends up being equal to a negative, you're never going to be able to put any value in for x to get some number inside the absolute value that when you take the absolute value of it will be negative. So you're done. We all right with that concept? Okay. All right. Then if I have, say, the absolute value of, let's say, x being less than, let's say, 5, right? What this means is, right, the absolute value of x is the same as saying the distance that x is from 0 is less than, and in this case, 5, right? So if I look at some number line, I don't know how to get rid of this now. Go away. There we go. So I've got a number line. I've got 0 hanging out here. I've got 5, and I've got negative 5, right? That means any of the numbers that are less than 5 units away from 0 in both directions, right? So all of these guys, up to but not including 5. So I'm going to put an open circle at 5, an open circle at negative 5, right? But I'm going to include all of these guys between the two because they're all less than 5 units away from 0, right? So this is what the absolute value of x being less than something means. So specifically, the absolute value of x being less than anything, a, let's just call it a, is the same thing as having a tripartite, which is just 2 inequalities smashed into a 3-way inequality, right? Negative a less than x less than a, which is the same thing as saying x is greater than negative a and x is less than positive a. So it just, either one of these, they're all the same thing, right? These 3 expressions are equivalent. That means that, and this means that. So if I go to graph something like, say, the absolute value of x is less than 20, That means I'm going to come in here. There's 20. There's negative 20. There are going to be opens there. And then it's just everything in the middle, right? What we might see, though, more often than just saying, oh, the absolute value of x is less than some number, is that we'll see the absolute value of some expression. So let's say 3x plus 2. And let's say that that is less than 5. Right? Now, in this case, I'm going to need to come back to these expressions up here. And I'll probably favor this double expression, right? Break it completely up. And so that means that x, whatever's inside the absolute value, so in this case is 3x plus 2, that is either greater than negative 5 or it's less than 5. So I get these two equations, two inequalities here. This turns into 3x plus 2 is greater than negative 5, or, not or, but and 3x plus 2 is less than positive 5. And I can solve each one of these, right? Subtract 2 on the left inequality. That gives me 3x is greater than negative 7. And then, sorry, jumping the gun here. Divide each side by 3. And I get x is greater than negative 7/3. And on the other one, subtract 2 from both sides, and I get 3x is less than negative 5/2, or sorry, negative 3. And then if I divide each side by 3, then I've got x is less than negative 1. And so I can graph this. There's my 0. There's negative 1 I'm going to be interested in. And, oh, the other one is negative 7/3, which is a little bit, let's just call it right there. Timeout. This should not be negative. My bad. So we want it there. Apologize. So, but I'm in between these two, right? I have to be greater than negative 7/3, which is the values to the right of it, but I also have to be less than positive 1, which is the values to the left of it, right? And so I'm just going to graph those by, you know, however, whatever that looks like, shade them in, right? But it's this, it's those numbers there, and it's an open because it's a strict inequality. Open circle between at negative 7/3 and an open circle at 1. And then my solution is just all of those values in between. In interval notation, that is to say, it's negative 7/3 with a parentheses up until 1, also with a parentheses. Are we okay with that? Okay. Let's take a look at another one like that. Yeah, let's do the absolute value of x plus 6. And I'm going to do less than or equal to, and let's go 10. So I've already got this isolated, right? It's the absolute value all by itself on the left-hand side of the inequality. So it breaks up immediately into those two inequalities. That x plus 6 is either less than or equal to 10, but that also has to satisfy that x plus 6 is greater than or equal to negative 10. And so again, I just subtract 6 to solve. This gives me x is less than or equal to 4. And minus 6 gives me x is greater than or equal to negative 16. And so I can graph this. I've got interesting values at 4 and at negative 16. X has to be less than 4, so that's to the left of it. X has to be greater than or equal to negative 16, so that's to the right of it. But since I can be 4 and I can be negative 16, these are going to be filled in dots. Solid dot there, solid dot here. And then it's those values in between. Or in interval notation, it's the values between negative 16 and 4 in brackets to include. Good with that? Okay. Then the other type of these is if I have the absolute value of something greater than some value. So let's look at maybe 3. What this means is the distance that x is from 0 is greater than 3. And if I look at what kind of equations or what kind of values satisfy that, it's all of these guys that are beyond 3, so they're further away from 0 than 3, or it's the guys on the other side that are further away from 0 than negative 3. And since it's a strict inequality, I would put an open here, and it would just be those guys on the outside, right? But what we can say then in general is if I have the absolute value of x or some expression being greater than some value, which we'll just call a for now, then this turns into whatever's under the inside the absolute value is greater than a, or the absolute, whatever's inside the absolute value is less than negative a, right? And this is an or because it's more inclusive. It's all those guys over there plus all those guys over there, instead of the and, which when they point at each other is just the intersection of each of those intervals. So let's take a look at how to play with one of these. Let's do this guy right here. The absolute value of 5 minus 2x is greater than or equal to 1. So again, already it's isolated. I don't have to isolate the absolute value here. It's done for me. So this just turns into 2 equations, right? And it's important to remember which one turns into which, right? The absolute value being greater than something means or, and the absolute value being less than something is an and. And so this turns into 5 minus 2x is greater than or equal to 1, or 5 minus 2x is less than, switch that sign and switch the sign of the number. And so I just solve each one of these. Minus 5 on the left inequality. That gives me negative 2x on the left-hand side, still greater than or equal to, and that would be negative 4. But as I divide both sides by negative 2, I get x, and because I divided by a negative, that symbol turns and becomes less than or equal to, then negative 4 divided by negative 2 is a positive 2. Or, same thing here, minus 5 from both sides, leaves me with negative 2x is less than or equal to negative 6. And then divide each side by negative 2. leaves me with x is greater than or equal to a positive 3. So those are my OR statements. If I graph this guy, it looks like this. I have a spot at 3, I have a spot at 2, and really I don't really care about any other numbers. You can put 0 if you want, but throw 2 on there, throw 3 on there. X is less than 2 is a solid dot at 2, and then a shade to the left. And then x is greater than 3 is a solid dot at 3 and a shade to the right. And in interval notation, I would write this as negative infinity up to 2, including 2, but of course never including infinities. Union that with bracket 3 to infinity, and again, include the 3, but not the infinity. We all right with that? All right. I don't see it anywhere else. There is one other type of equation, or equation that you might run into. So let me throw it out there just in case you run into it in your homework. But I don't see that the book addresses it. So one last type would look like this. So if I have, say, maybe the absolute value of x equals the absolute value of y. Right? X could be positive and x could be negative, and y could be positive and y could be negative. So this tells me a couple of things. That either x is equal to y, they're either the same value, or x is the opposite value of y. And that's the only two cases I have to consider. Because I could say, well, y could be the opposite of x, but that's the same thing as having x being the opposite of y. And I could say, well, they could both be negative. I could say negative x, the opposite of x is the opposite of y, but that's again saying the same thing, that they are the same value, right? So I have two cases. Right. So if I am faced with something like, say, the absolute value of 2x plus 1, is equal to, let's say, I don't know, 4x minus 7, right? Then I've got these two scenarios. Either whatever's inside the absolute value of the first part on the left-hand side, this is either equal to the other side, or it's the opposite of it, right? And so I'm going to write this down as this 2x plus 1 is either the same thing as the other side, so it's either equal to 4x minus 7, or that 2x plus 1 is the opposite of 4x minus 7, right? And this negative is going to get distributed through. So this right-hand equation becomes 2x plus 1 is equal to the opposite, minus 4x, and then plus 7. And then I'll just solve each of these, right? On the left-hand case, I'm going to subtract 2x to get them all the x's to the right. But I'm going to also add 7 to get my non-x terms to the left. So that leaves me with 8 on the left equals 2x. And then, of course, dividing each side by 2 gives me x equals 4. That should be one of my answers. I'll verify it in a minute. But let's get my other one. I'm going to shove my x's to the left this time by adding 4x to both sides. And then subtracting 1 from both sides. And so the 1 cancels on the left, the 4x's cancel on the right, This leaves me with 6x equals 6. Divide it by 6, and I've got x equals 1. So I have two solutions. Hopefully they're both right. Let's find out. I'm going to plug in 4. So that leaves me with 2 times 4 plus 1 in the left-hand side. Should be equal to the absolute value of 4 times 4 minus 7. But 2 times 4 is 8. And the absolute value, 8 plus 1 is 9. And the absolute value of 9 is 9. The right side of that equation, 4 times 4 is 16. 16 minus 7, well, that's 9. So in this case, they were the same, right? The absolute value of 9 is still 9. This guy checks out. Let's plug in 1 and see what we get out of that. So 2 times 1 plus 1 it should equal the absolute value of 4 times 1 minus 7. 2 times 1 is 2. So I get 2 plus 1, which is 3, and the absolute value of 3 is, of course, 3. The right-hand side, I get 4 minus 7. But 4 minus 7 is negative 3. And so this is the case where they were the opposite sign. This still works out because the absolute value of negative 3 is 3. And so those are my two solutions. Okay. Like I said, this last one I didn't actually see in the book, but that weirds me out because it's in every algebra course like this. So better cover it than to not and have you guys be surprised in your homework. So any questions on any of that we've done so far? Okay. If not, and I know there's only a few of you here, thank you for being here. But it's going to be a short day today because that's all material. And on, where's my calendar here for this class? Give me a second to pull this up real quick. Monday, so Monday the 17th, I'll be back down in UNLV. We're going to cover 4. That actually covers all of 3, chapter 3. So we're going to cover 2 sections in 4. That's 4.1 and 4.6. That's what we've got Monday. So I will see you guys then. If there's no questions, have a good rest of your day. Yeah, Savannah.
Sorry, I just wanted to clarify on the other problem where you said it was like no solution. So if there is any type of equation that's in the absolute value, like 9 for absolute value, and it equals to a negative number, then there's no solution to it whatsoever because absolute value is positive number.
You're breaking up quite a bit, but I think what you asked me is if it boils down to an absolute value becomes negative, there is no solution. Is that right?
Yes.
Yeah. Yeah, that is the case. If you ever end up with the absolute value of anything, doesn't matter what it is. If that's negative anything, you're done. There's no solutions.
Okay, thank you.
You're welcome. Any other questions? All right. You guys take it easy. I'll see you on Monday.